This is the video for the Unit 12 Graphing Polynomials review for our exam in the spring of 2018 for Algebra 2. And we're going to start on question 31. So this is with graphing polynomials. So when you think about roots are our x-intercepts of our graph. So if we have an x-intercept of, say, 2 here, we need to write it in factored form in order to get standard form, because they want us to have standard form. So if we have 2, we would write that as x minus 2. We flip the sign, and I can show you right over here why we do that. So if we have x equals 2 and we want to get it as a factor, we would subtract 2 from both sides. We get x minus 2 equals 0. So that's how we get the factor of x minus 2. So then negative 4 would be x plus 4. And then 0 is just an x out front, because it's like saying x equals 0. You would just have x. So that's our standard form. So you always want to write standard form first. I'm sorry, factored form first. Oops, this is factored form. Okay, and we're going to write it into standard form by using FOIL. So we're going to FOIL these two parentheses first. So we're going to leave this x on the outside. We'll handle that later. And so for our first terms, x times x, we get x squared. Outer terms, x times 4, we get 4x. Inner terms, negative 2 times x, we get negative 2x. And our last terms, negative 2 times 4, is negative 8. And so from there, I would simplify the inside first. So we have 2 middle terms that can combine. They are like terms. So we have 4x minus 2x is a positive 2x. And then we would distribute our x. So x times x squared is x cubed. X times 2x is 2x squared. And then x times negative 8 is negative 8x. And this is our standard form. So you start with factored form, FOIL, simplify, put my simplify stuff in here, okay, and then distribute that x again, and then we have our standard form. Number 32, so this is when we talked about conjugates. If we have a root that has I in it, there's conjugate pairs. So when we have negative I radical 6, what also must be a root of the polynomial is positive I radical 6. So we just change the value of I from negative to positive. So if we look at 33, if 5 and 4 plus 7i are roots of our quartic polynomial, what are or is the missing root? So we know that 5 does not have a conjugate because it doesn't have I with it. 4 plus 7i would have the missing root 4 minus 7i. So that's all we do is we just flip the sign on the term that has I. For number 34, if we have a polynomial with real coefficients I and 7i as 2 of the zeros, what's the least possible degree? Remember, degree is equal to the number of roots. Keep that in mind. So we already have one root as I, and we have one root as 7i. Well, we're missing 2 roots. We're missing negative I and we're missing negative 7i. That's a total of 4 roots. So if we have 4 roots, our degree, we would assume, would be 4. Okay, 35 says find a polynomial function in standard form with the given information. So part A says that there's a 0, or the zeros are x equals 3 plus and minus 4i. So we have 2 roots there. We have 3 plus 4i, we have 3 minus 4i. Let's just pretend we had x equals 3. If we were to write that as a root, we would write it as x minus 3. Because positive 3, flip the sign, we have negative 3. But the only thing that changes is our 4i's. We'll have plus 4i and we'll have minus 4i. So when you write those, keep in mind that you only change the sign on the i's there. The 3 was originally positive up here, so it's what changed on the inside. So then to get our standard form, we have to do distribution. These are a little bit bigger than FOIL because we have 3 terms in each. So you just have to have a pattern. So how I do it here is we take our x and we multiply it to the first terms. X times x is x squared. And we do x times the second term. X times negative 3. Negative 3x. And then we do x times negative 4i. Negative 4ix. All right, now we're going to go to the second term. I'm going to switch my colors here. We're going to go from at negative 3. So negative 3 times x, negative 3x. Negative 3 times negative 3 is positive 9. And then negative 3 times negative 4i is positive 12i. And we have one step left here. It's this 4i. So I'm going to take 4i times x. 4i times negative 3 is negative 12i. And then 4i times negative 4i is negative 16i squared. All right, now to simplify these, if you take a look at your terms, one thing I can always tell you about these problems is you will never have I in your final answer. And that's something I would make a note of because it's easy to accidentally miss a negative and then you have I left and you're like, what am I supposed to do with this I? So you should never have I in your final answer on these, okay? Because if you look, you have a positive 12i and a negative 12i. You have a positive 4ix and a negative 4ix. Now we're going to handle the I squared, but everything else is gone in terms of I. So we're going to go ahead and write down our simplified form. So we have x squared, and then we have a negative 3x and a negative 3x. That's negative 6x. We have this plus 9 left. And at the very end, we have the minus 16i squared. If you remember our discussion on I squared represents negative 1. So if we rewrite this, we can actually write it as 16 times negative 1 instead of 16 times I squared. So then we can simplify. Negative 16 times negative 1 is positive 16. And then we can add in 9 plus 16 there. 9 plus 16 is 25. This is our standard form. All right, let me make these a little bit smaller here, and then we'll do part B. We have to answer our questions at the top. All right, we'll move that over. Okay, so for this one, when we talked about degree, potential degree, we have 1, 2 roots here, so the potential degree would be 2. Okay, on part B, we have x equals negative 2, x equals radical 11, and negative radical 11. We're not missing any roots here because negative 2 does not have a conjugate pair. It's a regular number. We don't have to worry about having a conjugate pair. So there's a total of 3 roots here, so we have a potential degree of 3. So if we want to write our factored form, x equals negative 2 would be x plus 2. X equals positive radical 11 would be x minus radical 11. And then negative radical 11 would be x plus radical 11. So we just flip the signs on those. So on this one, I'm going to go ahead and FOIL the 2 parentheses that have radicals in it. So we'll do x times x is x squared. X times radical 11 is positive x radical 11. and then x times negative radical 11, negative x radical 11, and then negative radical 11 times positive radical 11 is radical 121. If you look at the middle terms, they're opposites of each other, so those are going to cancel each other out. So we'll be left with x squared minus the square root of 121. And we have to drop down our x plus 2. We haven't worked with that yet. Now, before we go ahead and FOIL these, we want to simplify the square root of 121 right here. That one can be simplified. So the square root of 121 is 11. So we have x squared minus 11. That's a perfect square. That should always happen in these problems. Whenever you do a radical times itself, okay, you'll end up with just the number that was inside. Okay, and now we're going to FOIL these to get our standard form. So do x times x squared, x times negative 11, 2 times x squared, and 2 times negative 11. Now to get standard form, you have to make sure they're in order. Right now they're not in order, so we want to put x cubed plus 2x squared minus 11x minus 22. Once they're in order, that's your final answer, that's your standard form. Okay, number 36. So here we have a graph. It says do not multiply out your factors when you write factored form. And then identify the stated characteristics. Okay, so our factored form. So look at the graph and see what our roots are. So right here, looks like our first one at -5. We have another one right here at -1. We have one right here at +4. And we have another one over here at +7. So if you write the factored form of -5, it would be x plus 5. We use the opposite sign. And then if we look at the nature of that root, it looks like a quadratic, an x squared function, so it's going to get a power of 2. Our next factor is x plus 1 because we have x equals -1 over here as a factor. Okay, and that looks like a straight line. A straight line just has a power of 1, an x to the first, so that's going to have a power of 1. X equals 4 would be a factor of x minus 4. And that right there looks like a cubic. So that's going to have a power of 3. And then our very last one is x equals 7, which will be a factor of x minus 7. And it's also a straight line, just like -1 was, and that'll have a power of 1. Now, if we want to get our degree, we add the degree on each factor. So we have 2 plus 1 is 3, plus 3 is 6, plus 1, total degree of 7 if we add 2, 1, 3, and 1 together. Right? So if there's a degree of 7, there should be 7 roots. Okay? Now we can actually see 4 places that it crosses the x-axis, but there is a total of 7 roots there. And if we look at our number of turning points, 1, 2, 3, 4, we have 4 turning points, but our maximum number of turning points is always 1 less than the degree, which would be 6. We'll make a note of that. Okay, now as x goes to -infinity, so that means over here, x is negative over here on this side. So as x is going to -infinity, this arrow is pointing up towards positive infinity for y. And then over here, as x is going to positive infinity, this arrow is pointing down to -infinity for y. Okay, so on this next one, we're kind of doing the same thing here, but we're doing it without a graph. Okay, so for our degree, same deal, we just add the exponents. So 2, if you don't see an exponent, then you assume 1. So 2, 1, and 1 is a total of 4. Okay, and we're going to, before we talk about this classification, we're going to talk about all the different ones. So if we have a power of 1, 2, 3, 4, and 5, okay, 1 would be linear. Power of 1 is linear. Power of 2 is quadratic. Power of 3 is cubic. A power of 4 is quartic. Power of 5 is quintic. And those are the 5 that we talked about. Those are the main 5 that we talked about. So in this case, since it's a degree of 4, we have a quartic function. And for our number of roots here, roots are equal to the degree. So we'll have 4 roots. Now take a look at the leading coefficient. So right here on our 2x squared, okay, 2 is the leading coefficient. And it's positive, so that means the leading coefficient is positive. Okay, and then think about the maximum number of turning points. Maximum number of turning points is always 1 less than the degree. So in this case, it will be a number, maximum turning points of 3. And then for a quartic function, that's a degree of 4, we know that arrows go the same direction because it is an even function. So arrows are going the same direction because it's even, and they're going to point up because there's a positive leading coefficient. So that means it would roughly look like this. So if we're talking about end behavior, both of them are going up, meaning both of them are going to positive infinity for y values. Okay, now we're going to build on this function. We're going to talk about the multiplicities of each 0. So right here at 2x squared, believe it or not, that x squared, that gives us a value of 0 on the x-axis. So if we go over here to our graph, okay, we can plot that point at 0, 0 because x equals 0 is going to be a factor. It's going to be a root. So behavior, okay, and multiplicity. Well, multiplicity is just a degree on x. So in this case, it has a degree of 2, so it has a multiplicity of 2. Well, we know if something is like x squared, that's quadratic, and we learned that it touches the x-axis. The only one of these, linear, quadratic, or cubic, that touches is quadratic. So if it's quadratic, it'll always touch. Then x plus 2 gives us a root of negative 2. Multiplicity of 1 because it has a degree of 1 up here. Okay, and it's crossing and it's linear. So it's linear because it has a power of 1. And if we were to look at the graph, it would cross straight through that axis. Same thing with 3. 3 has a multiplicity of 1. It crosses and it's linear. And we're going to see that here on the graph in a few seconds. The y-intercept. When it says determine algebraically, it means plug in 0 for x. Because we know for a y-intercept, x will always be 0. So we're going to take our original function, and we're going to plug in 0 everywhere we have x. Okay, so if we look at 2 times 0 squared, that's 0. 0 times 2, or 0 plus 2 is 2, and 0 minus 3 is negative 3. Well, because we have that 0 in there, those all multiply to 0. All right, now it says use a graphing calculator to graph the function. So we're going to grab our graphing calculators. And we're going to go into y equals, and we're going to plug this function in. Okay, now we should see our x-intercepts of negative 2, 0, and 3 here, and we do. Now, that looks pretty good, but if you look up on your notes to this box right here in the right-hand corner that says Y min, Y max, all of that, that is going to tell us the table that we need to put into our window. So go ahead and go back to the graphing calculator. We're going to press the window button right up here. So choose window. And we're going to scroll down. Negative 10 is good for X max, for X min. X max is positive 10, Y scale. Okay, Y min needs to be negative 40. Y max. Oops. Sorry, friends. Go to window. Back down to Y max. Y min should be negative 40. Y max should be positive 40, and we should scale it by 10. So that should be your window. And then you can go back to the graph. Okay, and we're able to see that full graph. So whenever we give you that, make sure you can see that full graph. Okay, so we should have a root here at negative 2, a root here at 0, and a root here at positive 3. So before we continue, let's go ahead and roughly sketch this on our graph. We already had our 0 on there. Here's our negative 2. Here's our 3. And it doesn't have to be beautiful. Okay, roughly something like that. And that covers part E, getting that rough sketch. Now part F says label all relative maximums and minimums on your sketch. So if we look at our sketch, we have a relative minimum here and a relative minimum here, and we have a maximum here. We already know that maximum is 0, 0, so you can go ahead and label that. Now, we're not just going to count on our calculator for these, we're going to actually trace them. So go back to that calculator, and to trace these minimums, we press second trace. Second is the blue button up here, and then trace is at the very top. And we're looking for the minimums. So we're going to choose number 3, and we're going to do our left bound and our right bound. I'm going to use my arrows to go from left to right here. Okay. All right, so that's a pretty good left bound. There's a go to right bound, and then we'll do a guess. Okay, so that minimum, go ahead and label this on your notes, is negative 1.39, comma, negative 10 point, we'll say 35, if we round. I guess I should round this one as well. All right. And then we'll do second trace, minimum, left bound and right bound and guess. All right, that one looks like 2.1 and 2.15. Comma, negative 32.61. So go ahead and make sure you label those. I'll label them over here. Okay, so now that we have those labeled, we've taken care of part F, and we can get to our increasing and decreasing section. So for increasing, that's where the graph is going up from left to right. So from right here to right here, our graph is going up from left to right. Same thing right here, up from left to right. So those are going to be our increasing sections. And we name these by X values. So if we look right here, that X value was negative 1.4. So we'll say negative 1.4 to 0, because it stops up here at 0. And then our second is from positive 2.1 to infinity, because we have this arrow. So So those are our two increasing sections. All right, and let's look at decreasing. So decreasing is this guy here and this guy right here. So decreasing, we're at negative infinity over here because we have this arrow and it stops at negative 1.4. And then here we go from 0 to 2.1. The biggest thing about increasing and decreasing is remembering to name those by x values. Now for our domain and range, kind of have a lot going on here. So I'm going to actually erase this. I'm going to redraw it quickly. We're going to need this point right here. So I'm going to rewrite that back in. Okay, now for our domain. Domain, since we have arrows on the ends of our graph, that's going to be negative infinity to infinity. Or you can put all real numbers. For our ranges are y values, so that's going to be bottom to top. So our bottom value is negative 32.6 for y, because we're talking about y values. And we're including that value. And then since our arrows go up, we don't really have anywhere that it stops here, so that's going to positive infinity.